Hi everyone, this is a tutorial on how to use Desmos to graph data in science. Okay, so if you open up the Desmos Science template, that's a really good starting place, and it has pre-programmed a lot of the features that you will already need to make an effective graph in science. Okay, so please don't fiddle with lines 1 and 2. They will make your graphs appear. Line 3 is where your data table is. So for the purposes of our work here, I'm just going to enter some random data. Okay, so you can see that our data points appear. All right, now we don't know what I'm graphing and I'm easily confused. So let us go ahead and explore editing our axis labels. So if you go up here and click on the wrench, that's your graph settings. Okay, and this looks very confusing, but you want to take a look at the x-axis and the y-axis. So in this box, you can click the x-axis label. You can just highlight what is in there right now. And let's say this is distance. And please don't forget your units. And we'll say we're measuring distance in meters for our pretend experiment. And actually, I'm a physics teacher, and you usually want time in seconds on the x-axis, and I'm going to put distance in meters on the y-axis, and look how that magically appears to label your x and y-axis. All right, now we want to effectively scale our graph to see all of the data points and the origin and the error bars, but not much more. Okay, and it looks like we've got quite a bit of unnecessary white space over here. So let's scale our graph. Okay, so we can do some stuff like just click and drag. Okay, that looks good. You can also zoom in and out using the plus and minus buttons, right? Zoom in, zoom out. That's not going to be super effective because we essentially need to cut off the right-hand side of this graph. So if we go back into our graph settings button, down here, underneath your x-axis label and underneath your y-axis label, it lists the smallest x-axis value that is showing on your graph and the largest x-axis value that's showing on your graph. And you can change those. So if I look on my graph on the x-axis, my last data point is 5. So if I go just beyond that, I could cut off my graph right here at 6. So if I cut off my graph at 6, there we go. See, that looks a lot better. And you don't have to be perfect. You can even pick this up and drag a little bit and make it exactly how you want it still. All right, now let's find a line of best fit. Okay, so down below here, there are multiple lines of best fit. We've got horizontal, proportional, linear, simple, quadratic, and then inverse. If you would like to add an additional expression, simply click in an equation and press enter, and then it will give you a new line. What if I wanted to do inverse squared? I could just do y equals, and then a is generally your the constant, right? It would be the slope in the linear graph. And then I'll do a slash, and it automatically makes it into a vertical fraction. And then let's do over x squared. Okay, to do a squared, you want to type x and then shift 6 as a caret to indicate exponent, and then a 2. Okay, so that would be inverse squared. All right, now each of these have a different color button, these little swishes. And watch this. If you want to see what your line of best fit is, you can just come down to this A equals button, and there's a slider. Right, and you can slide that slider, and you can see how each relationship changes. So the red line on the graph is associated with this red, the equation that's next to the red dot. The blue line is associated with the blue line on the graph, green on green, and so forth. Okay, so let's adjust this until it fits our dots. Perfect. So it looks like our green line is what we want. So I can unclick all of these dots. You don't want to X out the equations because then the equation will go away, but unclick each dot. And then you just have the line of best fit that you want for your data. Okay. If 0 to 50 isn't correct for your slope, you can simply click here and you could increase this so that the possible slope goes up to whatever it is you're interested in, 300 or something. Okay. You may also, if there is a y-intercept, that's what B is the y-intercept, and you can slide this around to adjust the y-intercept. All right, and then finally you can put in some horizontal and vertical uncertainty bars associated with your experimental uncertainty values. Okay, so watch this. So I can increase the horizontal uncertainty. Let's say horizontally we had an uncertainty of 0.3 seconds. Vertically for distance, we had an uncertainty of half a meter. And so what you get is, instead of error bars, you get error boxes. And that box encompasses the uncertainty associated with your individual data point. Okay. For these arrow boxes, you should choose the uncertainty for the largest uncertainty of the data you collected. This is not for editing. Line 16 is not for editing. It includes the code that allows those error boxes to be created. All right. And then finally, some of you might be interested in finding the R values for your regressions. So let's say that this is your line of best fit. To find the regression, you actually have to, instead of writing Y and X, you have to label them X1 and Y1. So let's say X or Y1 and X1. And you also have to, instead of an equal sign, you have to make this squiggle. Okay, and then it gives you the R values down here.